So let's assume that we know that the square root of 35 is irrational, and proving that is pretty similar. It's a little bit trickier than proving the square root of 5, but let's assume we know that that's an irrational number. And here's a nice little fact you can get out of that, that the square root of 5 plus the square root of 7 is irrational. We already saw that you can take irrationals and add them and get a rational, but there we did something clever, like root 5 plus or minus root 5 or something like that. This one, the claim is that that is actually still an irrational number, that the irrationality doesn't cancel out. It's essentially that the root 5 and root 7 irrationality are somewhat different, maybe. A little bit, you can say that a little bit. Okay, so well, again, irrational, kind of a negative statement. Makes sense to use proof by contradiction. And the other thing is that we want to be able to do something. It's very tempting to do something with this thing. Because this is a square root, it's something that's being cried out to be squared, or it's involved squared, so it's cried out to be squared. And the thing is that the easiest way to get a hold of, hey, I want to manipulate root 5 plus root 7, is to assume something about it like it's rational. Okay, assuming that, for the purposes of contradiction, of course, then its square is also rational. But that's going to be root 5 squared, which is 5. Aha, there's a payoff. Plus 2 root 5 times root 7, there's a times, plus 7. Okay, so that's 12 plus 2 root 35. Aha. So we're asserting, based on our assumption, that that's rational. Okay, but if that's rational, then that minus 12 is rational, and then that divided by 2 is rational. Then this has to be a rational number. And that we're assuming that someone has already given us an airtight proof, or at least maybe a sketch of proof like in the previous video, that one was irrational, and there's our contradiction. Okay, so that's a cute little thing where we're getting a little more into the algebra. I think that the new feature of this is that we really had to actually know something about the algebra, in particular the great formula a plus b quantity squared is a squared plus 2ab plus b squared. And if we don't know algebraic facts, we're not going to be able to go super far into proving things about that are defined in algebraic ways. Okay, so that's a nice, quick, and easy one. Okay, so we can leverage, the idea there is we can leverage certain facts about irrational numbers to prove more and more and more. And we're going to see a little more sophisticated example of that in the next video.